So today again we'll discuss some basics itself. We'll try to understand what exactly Terraform providers will do. So Terraform provider is a plugin or maybe a driver kind of code. Say through this provider, Terraform is going to communicate with the like a provider that's maybe AWS, Azure, Ali Cloud, whatever it may be, it's going to communicate. Okay, so then it's going to expose the resources and data sources. Say here we have two things very important. So one is like resource, second one is data source. What are all those we'll discuss. Say like in like AWS, so more than 1100 I think resources are there in the AWS, and around 750 somewhere data sources. All that code itself. Providers have been written. Okay, that means that templates itself they are going to specify, and we are going to use resource blocks. Say any idea what is the resource blocks we use? Say we use like AWS underscore instance, AWS underscore VPC. Like this, providers are giving us the templates or declarative templates for all the resources and data sources, and it's a open document. So that means in the Terraform documentation, everyone can get that, and which we can use in the Terraform configurations to like we are declaratively declaring these resources I want, say in the form of HCL, and that's backend that's may use some Go language. Then that Go language with that is going to authenticate with the AWS SDK and it's provision those resources. Okay, so that's provider code has been given by that provider code has been given
Terraform.
by the Terraform. For the most of the providers, Terraform is providing. There are some situations. I have one product. Terraform not accepted to develop a module. Then that company also can develop a module. Sorry, provider. Okay. So most of the cases for the like why that company may give their clients Terraform provider is their business also may increase. Okay, but for the major cloud service providers, most of the other like Kubernetes for all these, Terraform itself is providing. Terraform provider expose two things for us. One is resources, and the second one is data sources. Okay, so we have both that resources and data sources. We'll understand. And if you go to the plugin, normally when we do the plugin, so when that is going to be like plugins are we are getting into .terraform directory. Whenever we do the Terraform init, it downloads those required providers into .terraform directory. Okay, and it's going to communicate over like APIs or SDKs. All that is going to communicate. And for that authentication, it's mandatory. What we required is in the authentication what we required, say we required those credentials like access key, secret key or role, all those we required, we can pass them through AWS CLI we pass, or we can pass them through environment variables, or credentials files, or IAM roles also, or in the block also we can keep, but that's not a best practice. So now here we are passing a profile is DevOps. If I don't pass any profile, by default, it takes a default profile. If I don't specify any profile, it is taking a default profile, but depends upon our requirement. We need to take which profile we need to take. And for the profile, we'll have a versioning also. Say, if we want any specific version, that version we need to use. Okay, so that's we need to understand those versions also. In this use case, whenever we are using this Terraform init, which version specific you want, so those also we need to declare, so those also we need to specify, those versions also we need to specify. Okay, so that means here we are using source is HashiCorp/AWS. That means in the Terraform registry, like in the AWS provider, it is downloading. It is downloading. Okay, so that means here we have different symbols we have. So that's we use here the symbol, right? Okay, so what is that meaning is any of the 5.x version is fine. Any of 5.x. So what is that meaning? That this
Yes.
symbol, what is this? That your understanding of
I mean, if it is 5.x, maybe the later version as well, 5.1,
no,
5.2,
not
maybe.
6.x.
5, I said.
5 only. In the 5, whatever
5.1,
it may be.
5.2.
Yes, that is fine, but not the higher version or lower version. You want any specific version, then say directly you need to give here. Directly that equivalent we need to give. Okay, so that's otherwise any higher version than that, then directly you can use greater than or equal. I hope you understand that the differences. Okay, so then here if I specify like not equivalent, okay, so even that is also one of the regular expression pattern we can use. That specific version we don't want. We have some issues with that. Other than that, anything is fine. Then we can use. I hope you got it right. These all we need to understand which provider version we need to use, and the Terraform init is going to download this from that from the Terraform registry. It's going to download. Okay, and here we have the different versions, providers we have. For AWS, what is the provider name is? AWS itself. And for Azure, what is the provider name for Azure?
Azure RM.
Azure RM is the provider. It's not Azure. Okay, Azure RM. For GCP, Google. Okay, for Kubernetes, Helm, Vault, GitHub. Okay, so it's not only cloud. We have lot of providers we have. Okay, and in some use cases, Terraform supports multi-cloud kind of environment also. We can pass multiple providers also. So one of the problem with the CloudFormation or Azure ARM templates are those not supporting. Those are not supporting like multiple providers. It's only AWS CloudFormation, but I have a different environments in which use case we are going to use the two different providers. Is one use case is we are using one provider for AWS, one provider for Azure. Okay, so that is the use case we can go for. That is the use case we can go for. Like two different providers we are keeping. Second use case is I want to use AWS itself, but I want to use two different accounts, two different regions. Then I'm going to specify two providers. I'm going to specify not only two, we can declare the multiple providers. Can you tell me the use case when we'll go for multiple providers? Can you tell me the example? When we will go for multiple providers, can you tell me the example? I want to use one provider for AWS, one provider for Azure. Our second use case is in AWS itself, why I am using two providers is I want to use two different accounts, two different regions I want to use. Normally in the CloudFormation, we have one solution for that. Any idea?
Yes, we use named profiles.
Not named profiles. In CloudFormation, I'm asking. The AWS CLI, we can use named profiles.
Yes, yes.
In the CloudFormation wise. In the CloudFormation wise, we have the stack set. Okay, I want to use AWS one provider, two different accounts or two different regions. If I have, then I need to use the stack sets. But here in this use case, try to understand what is the provider AWS. I given one is prod. For the second one, alias dev, I given the region is US West 2. For the prod, both are AWS providers itself. But why I am using two providers are one I want to use in US East one and dev I want to use in US West 2. Okay, so in this use case, whenever I'm creating that provider, I'm using that alias name. I'm using that alias name I'm going to use. Say with this, what is going to happen? If I use the alias, what is going to happen? This prod, AWS.prod, what it is going to use? like US East 1. If I use AWS dot dev, then it's going to use
West 2.
West 2. Say, in which use case you are using multiple AWS providers? We have two different
Regions.
regions or two different accounts you want to work, then you are going to use. Otherwise, in the hybrid cloud environment, I want to use AWS, I want to use Azure. On premises, I have VMware. Then I'm going to declare three different providers I'm going to specify. Okay, so then even we can use the nested providers also. As of now, not required. And say don't tell you have created a custom provider. We are just using that providers itself is enough for us. We are not developing. Maybe any company or product-based company, we may have their own special requirement because Terraform is not providing the provider. Then that company itself will provide. What is the advantage to that company? Their business maybe increases if they give the Terraform provider because clients may use that. Because a lot of companies maybe are a lot of clients, but Terraform not accepting that much downloads they don't have, then they don't invest on that provider development. Okay, so that's even customer providers also, but we are just using multiple providers. We are using like that. We need to tell. Okay, and always we need to log the versions also. For that, we have one hidden file. Any idea what is that file name? So when we do the Terraform init, additional to .terraform directory, this file also is getting created.
Log file.
Yeah, Terraform
HCL.log.
HCL.log file is getting created. Terraform HCL.log, always that will make sure that log itself is going to use. And don't pass any sensitive details. Okay, in the like providers. Okay, and use the Terraform provider. All these also like multiple providers also we can use. Okay, so then even in this they're using both provider Vault. They're using provider AWS also we are using. So like this, even AWS and Azure kind of environments also we can create, depends upon the requirements. So it depends upon that requirements, we can create those also. Okay, sure. Any doubts? Then like we discussed, right? Terraform is going to provide that resource blocks, and the second one is data source blocks. Resource is a straightforward. Whatever the resource you want to create, that Terraform will specify that resources can be created. Say, I want to create an AWS EC2 instance or EBS volume, network interface, VPC, subnet, internet gateway, route table association with the subnets, elastic IP. Everything is a resource. Like AWS provider will give that a declarative updates for all those resources, how we can specify. And in the documentation of the Terraform AWS documentation, they will give each and every resource name, all those like arguments what we can pass. Everyone in the world need to use that documentation itself. Everyone need to use that documentation itself we need to use. Okay, so what is that meaning of resource block? So which resource you want to create, manage, destroy. We are getting already a template kind of thing, and that resource has been specified by Terraform in their provider, and we are just using that resource block. So already when we use this, so this block we are using, right? So now in this, can you tell me what are the keywords we have? So in that, what are the keywords in that highlighted one? Resource is the keyword, and AWS underscore instance is the keyword. And what is the name we are giving? Web underscore server. And whenever we want to specify that resource, AWS underscore instance dot web underscore server, I can't create one more in this like a workspace. Okay. Yeah. Any doubts on this? So that means here
I mean, we
this is
can't create multiple web server instances at a time.
no.
You mean
This
to
is
say?
just from the Terraform wise the name. If you use the
Uh-huh.
counter, a index would be
Okay.
created 0,
Mhm.
1 like that.
Okay.
So we can here in the tags we can give, but here we can't give
Mhm.
this.
Mhm.
If I want, say suppose manually itself, if I want one more resource block, what I need to do
Okay.
is,
Mhm.
so I need to
Understood.
keep like this.
Hmm. So that is instance type and name we
This is
can
the resource
instance.
type. That means
No, no. Here web server.
That is
web
resource
server,
block name, I
web
think.
server is that instance name, but here it won't allow because already in that Terraform we have already that name.
Correct. Huh.
That is the reason here I need to give maybe web server 1 like that I need
Okay,
to give.
fine. Instance name that is okay. Got it.
From the Terraform wise, not from
Mm-hmm.
the GUI wise. In the
Mm-hmm.
GUI wise, this name we are getting.
Okay.
Okay, this name we can give duplicate because AWS supports that.
Okay.
Okay, even if AWS doesn't support that also we shouldn't give.
Yeah, understood.
Okay, so that means what is the resource block is in the provider we are getting these resource blocks, and for each and every resource there is a keyword, and that keyword we need to use, and all these AMI instance type, these all you no need to like remember there is a proper documentation. Okay, so from the documentation itself we are going to perform all this. Okay, and whatever the values you want. So now, like even if you want to create around 200 resources, everything we can create from that resource block itself. That means Terraform provides AWS documentation, Azure documentation, Kubernetes documentation, VMware documentation, Google documentation. That documentation we need to understand. And your provider is Azure. Say 1 week, spend lot of time on that, and in that, like we may have some hundreds of resources are there. You no need to worry about all the resources in your project. We may have 30 to 40 resources. Go through each and every word about your project resources. You got it right? That 30, 40 resources itself, maybe duplicate, maybe we are creating. I'll tell one example, maybe 4 VPCs, 20 subnets. Like this, we are 20 subnets, S3 buckets. Like this, we are creating 200 resources, but all are again in this like resources itself, it's a subset kind of thing. Okay. So now resource block will give us declarative updates, how the resources can be provisioned on that provider, and all the resources, mostly like AWS 1 or 2 resources may be not supported, but most of the resources it provides the declarative updates for us. Okay, and additional to resource, we have one more is that data block also we'll discuss. And in the Azure wise, like this resource name is Azure RM underscore resource underscore group. Say, is it necessary to remember those all the names? Important one, you try to remember, but everything we can get it from
Documentation.
from the documentation we can get. So we can get those from the documentation. We need to get that. How to follow the documentation also we'll discuss. Then additional to resources, we have one more is Terraform data source. So now, what is this Terraform data source? We'll discuss. This is also very, very important. Like resource is a straightforward. We are creating a resource, but what data source will tell us is, okay, say it's going to, like already one resource is existing. I'll tell one example, try to understand. A little confusing as of now. Maybe going forward, we'll discuss. So now here we have like already a VPC is there. Now, if I use resource, okay, AWS underscore, sorry, VPC, then main something I have given. If I give this resource block, that resource is again is going to create a, but what is my requirement is already resource is existing, then that is not my resource. Some other team has been created that, but what is my requirement is in my project, I need to create my own Terraform. I need to create my subnets I need to create. Means VPC is the, say if I import that resource, what is the problem? That is not my VPC. I hope you understand, right? We can do importing right here, but importing is not allowing here. What is the problem? That is not our VPC, but still my business requirement is I want to use the VPC, but I can create my own subnets. Then if I create a resource block, it's going to create a
VPC.
new VPC is getting created. But I don't want a new VPC. What I want?
Subnet.
Only subnet. Then I need to use that as the data source I need to use. Okay. So that means that VPC I'm going to declare as the data source. Okay. Then I'm using resources subnet I'm using. So can you tell me your understanding what is the difference between resource and data source?
Resource means we are creating it. Data source means
Directly,
already exists.
straightforward, it's going to create a resource. Then what is data source?
The existing resource.
Data source is already existing resource, not in our Terraform. Our state file also doesn't know. Okay, that's the reason if I again declare that as a resource block, it will create a new resource. But on that, I want to create most of the child kind of resources. I want to reuse that resource, but that is not in my Terraform scope. That is outside my Terraform. That's maybe created manually, or other team also may be created through Terraform. But I want to use that as data source I need to use. And even in this new tutorials, like when we create the data instance also, that Ubuntu, they have specified the AMI, because AMI is a very dynamic kind of resource. We don't know what is the AMI we use in the region. Previously, what we used to do is for the Ubuntu 24.04 itself, for North Virginia, that AMI ID is different. For US West to Oregon or Ohio, that AMI is different. Okay, then what is the problem is, for each and every resource, I need to specify that AMI. But if I use the data source, dynamically it is retrieving that value. Dynamically it is retrieving that value. So these all like for the resources, data sources, how to use, like who is providing? Terraform is providing through
Data source.
Through data, not data source. Through the provider. Okay, through the provider, they're providing this. Okay. Any doubts on this?
So that means images will be different for each region?
Each region, yes. Ubuntu, even if you use 24.04, that AMI ID is different.
Okay.
Because these all are the scope of the region level itself. EC2, S3, RDS. Even some resources are at zone level also. If I have an EBS volume, that EBS volume server may be on one zone. Okay. Some of the resources are at zone level. Some of them are at the region level. Some of them are at the global level we have. Okay. So that is one of the example why we need to use the data sources. Okay. So now in this example, try to understand. Here, I have already this VPC is there. Okay. So then I need to know that existing VPC, but instead of tag name, better to use that VPC ID. So here they use in my project or in my account, like if any of the VPC contains the name main-VPC. Here, if I create a resource block, it's going to create a new resource. I don't want that. And what is the name we have given? From the Terraform wise, what is the name we have given here?
Data.
Come again?
Data.
No. Data is a keyword.
Sure.
Selected is the name we have given. Previously, we given AWS underscore instance web server we given, right?
Mhm.
Okay. So now here we given the selected is the name from the Terraform wise. But in the GUI, what is the name we have?
Main hyphen VPC.
Main hyphen
VPC.
VPC. Then in this scenario, what we need to do is whenever I'm creating a subnet, okay, what I'm passing is VPC underscore ID equal to that data dot AWS underscore dot selected dot ID. That VPC is not in our Terraform, but still we are using that. That means this subnet is going to be created under that
VPC ID.
under that VPC, under that VPC. Say here, if I use a resource block, it's going to create a new resource. I don't want that. Okay. And the second use case, what we discussed is we have the latest Ubuntu AMI. Then here this like we can search based on the Ubuntu name we are going to give. Say Ubuntu like this 2404 you want. So from these values dynamically in that region, whatever we have, it is retrieving. And who owners means we'll have our account ID, right? Okay. So here because that AMI ID value may be different, but Ubuntu 2404 like this, that value is not changing. Those values are not changing. Okay, so that is the reason we are going to use the data source and it's going to retrieve those IDs dynamically. And whenever I got that in my AMI, like data AWS underscore like AMI dot Ubuntu dot ID, this value manually I need to pass, but for every region it's keep on changing. Then manually instead of doing that, if I use a data source intelligently, that is retrieving that data for whatever is the region, dynamically it will get that value. So this is also one of the use case we can use data sources. So we can use the data sources we can use. Yeah, any doubts on this? So these all the specifications we'll get from the documentation. The documentation also will go through that. So now what is the resource is? It creates, destroys, or manages that resources. Okay, but read the existing infrastructure data sources are working. We can't create that because that is not our resource. We're just using that. I hope you got it right. So for VPCs, AMIs, other teams also sharing those, and those are not in our Terraform scope. Outside of our Terraform we have, then we are going to use this data source block. The keyword is data. And for resource, the keyword is resource. And all the templates, we have the naming conventions. Then we can give our own name. And based on that, we can use those values. Okay. So data sources we are using even for the secrets also. Okay, this use case also we'll discuss. So data dot we are going to specify. Then here we already discuss about the locking, right? Say which version you want. So that's going to be stored in the terraform.log.hcl. Okay, what is the main advantage is if you have the higher version of provider, each and every time if the Terraform init will do, okay, so that's we may get some issues with the existing infrastructure. In order to avoid that one, okay, so we are going to specify terraform.log file, which version we want to use, that exactly is going to match. And whenever we are going to upgrade our Terraform provider version also, make sure we need to take a backup of this file. Okay, so and everyone want to use the same version for the consistency. better security, and that provider version with which command is going to download. With the Terraform init is going to download, right? Then if any of the issues in the provider version, if they any have checksum issues, then that gives lot of unexpected errors. Okay, that is the reason whenever like we have uploading, downloading the files, is one of the best practice in the software is we need to verify the MD5 kind of checksums. If we verify with the size, there is no guarantee that exact files have been transferred. That is the reason once we upload or download the files, it's mandatory we need to verify the checksums. Because if the provider is not downloaded properly, that gives unexpected kind of errors. There is no problem with the provider, but where is the problem is? In our environment, we have the problem because the provider is not completely downloaded. It may be a corrupted kind of state. And if we install different versions of the providers, also some resources, we may get the conflicts kind of things. In order to avoid all these things, we are going to maintain terraform.log.html. In our Terraform workspace or in our Terraform project, it's a hidden file. When we do the Terraform init, automatically this file is getting created. And which versions we need to use and those hashtags for the checksums, all these details are going to be stored. Okay, so that's not at all recommended. Not at all recommended to manipulate that file. Manipulate that file. Even if any newer version is available, also based on this Terraform that log.html file, it is not going to download that. Okay, so then we can do the force upgrade also. So there, I don't want that version. A newer version is coming. So with the newer version of providers, some features may not work. Okay, then definitely we need to upgrade also. Okay, say new features are there. That's maybe not supported with the older versions. In that use case, what we are doing? In that use case, what we are doing?
We need to
We are
upgrade.
upgrading our because if a new service came, that older version of Terraform provider may not aware that resources. Okay, so in that use case, we are going to do like upgrading also to the higher version is one of the best practice to upgrade. But we need to have a backup of that also. Okay, and we need to like a new log file is going to be, but better to have a backup and don't do it manually. Don't edit that. Okay, so we no need to do it anything manually. Is going to be like automatically is going to manage. But in the team-based environments and multiple team are there, this is one of the like best practice. Okay, for the modules, it won't lock only for the providers. Okay, so then updates the log file. Init upgrade the latest versions. Terraform init -n upgrade will bring to the latest versions and logs also is going to generate a log file. Okay, so then we can use the mirror kind of thing also we can use. Then we'll discuss, say, suppose we have an older version because we may be keeping 3 to 4 years of experience in the Terraform, right? We may have the older version. Definitely, we need to upgrade to the higher version of providers. In our environment, we don't have much resources, but in the production, all the resources are tightly dependent on the Terraform wise. If you have any higher version of the provider came, like very carefully, we need to perform. And the compatibility checking, all these we need to perform before doing the upgrade of the providers also. Okay, so then we need to check the compatibility and any issues will come, idempotency, and even if you do the Terraform plan and apply next time, it shouldn't cause any problems. Okay, and with the multiple environments also. Okay, so then definitely we need to take a backup of that new project need to be created. Then like a state file backend need to be backup should be taken, or versioning should be taken. Log file also backup need to be taken. Okay, and all the changes resource wise, data sources wise, any changes, documentation, all that. Maybe some old arguments they may have removed, and new arguments they may have given. Those also we need to specify. Okay, so then we need to perform in the non-production environments. Then we need to do it in the higher versions. Okay, so we'll do some higher versions of the providers also will take. Okay, so that's we need to use the Terraform init -upgrade we need to perform. Okay, then it's going to bring, but before that we need to take the backups. All these also we need to perform. Okay, some resources may throw some issues at the plan and apply level. Those also, as per the new provider documentation, we need to resolve that. Some arguments may be removed, some resources may be removed also. That's all we'll get a change log or release notes. We are going to get that. And even if it is like not working, a lot of issues we are getting, then sometimes we may roll back to the previous versions also. Okay, so these all we need to perform. Start with the dev environment. Then we are moving to the production and staging and production environments, and the proper backups also is required. Yeah, any doubts on this? Yeah, any doubts? Then we have the Terraform input variables also. Just like in the CloudFormation, we have the parameters. We can say if we don't use the input variables, we don't get much reusability, and it's not one of the best practice, because we shouldn't use any of the hard-coded kind of values. And if we don't have the input variables, what is the problem we are getting is for different environments, we need to declare different input variables we need to declare. So that is also one of the challenge. So just like in CloudFormation also, we have the parameters are nothing but input variables, and output values also we have. Okay, and for this we are going to use. So now here in the basic folder structure also, whenever we are creating this, so now here mostly we are keeping main.tf. Sometimes we can keep even providers.tf also separate file we can use. Then variables.tf is another file we have. Then we are going to store in outputs.tf also is another file we are going to declare. And some of the other things we can keep versions.tf also one file we can keep, and backend.tf also, like what are the remote backends we have. Okay, so like this here we are going to divide these into separate folder structures we are going to create. Okay, so mostly in the main.tf we are going to keep all the resource blocks itself we are going to keep. Okay, so then coming back to that documentation for all the resources, this is an open documentation, not for someone. You can search for AWS Terraform like a provider documentation. It's a lot of companies in the interviews also tell to use this documentation also. From this also we can write the resources. So from the Terraform registry is the place where we have all the providers, all this. Okay, so then here we are using the older version, but you can download the latest version. That means go through this documentation, what exactly we are using the version, and that should be compatible with that. Okay, so means in your project you are using 6.x, then make sure to use the 6.x itself. Then here in these all the services, and in that services we have all the resources also. Like this here in this documentation, what we are getting is we are getting more than 1000 plus or 1150 plus resources. So not 1150. Here in this version, how many resources are available? How many resources are available?
1509.
1509. In the higher version, some resources may be removed and the newer versions, new resources may be given. And around 608 data sources we have. Okay. So now I'll go for maybe VPC kind of module. And in this, if I go for the VPC, so virtual private cloud. So now whatever the resource you want for everything here, there would be a documentation. Okay, I want to create a VPC. Then here I have AWS underscore VPC. Then in the main.tf, I'm going to keep this block. So this I'm going to keep this block in my main.tf. Okay, so then try to understand here. Resource AWS underscore VPC. Main is the name. I don't want main. Then I'm going to give the name is ITCM VPC. I'm giving and here this here also ITCM VPC. I hope you got it right. And I don't want 10.0. I want 10.10. Like this here, you can change these changes. Remaining all will document from this itself. Then the next one is I want 2 subnets or 4 subnets. I'll copy that subnet block also from this. I'll copy that subnet block also. Then here AWS underscore subnet main I don't want. Okay, I'll give my own name. ITCM public 1A subnet. Then my own say 10.0 it won't take because VPC is in 10.10 series. Then whatever the name you want here, you can give that names also. This is in the GUI, these tags are going to be declared. Then here this will throw an error because it is trying to create with the main.id, but that's we have modified, right? Then here we need to give ITCM and VPC. This, if I specify what is the thing we are adding is we are adding the relation between that VPC and this subnet and this is called as an implicit dependency. It's not an explicit dependency, but how we are linking that VPC and this, if I don't specify this block, what is going to happen is it is going to be created in the is going to be created in the it is going to be created in the default subnet itself. But in the default subnet, that CIDR block doesn't accept. Okay, so that is the reason what we are doing is we are adding that VPC ID. So we are adding this VPC ID, but the relation between these two are I need to modify this one. Okay, so this is very easy for us. But we need to understand the differences between those resources. Okay, so then I want 4 subnets. Then here you copy this block itself. And as per your requirements, you try to modify those. Okay, then I want like maybe one route table. Then I'm going to create a route table here. Means if you are using AWS VPC, make sure all the resources you need to understand. Now AWS route table, I'm giving example. In this I have 2 routes I'm going to give. Okay, so one for the internet gateway or like by default we want to get one like internet gateway like this. These all we need to create. Then one route also we can add. So these all the resources, whatever we have, each and every resource and data source block documentation is available. Just we need to use those and try to modify some like changes as per your requirements and what are the things we want to change and which we shouldn't change. Okay, we need to have a knowledge. So this documentation like is again like very important for us. Anyone in the world need to follow this guideline if you are using that specific version of provider. Okay, so maybe if you are using another provider, better to go through that documentation. Okay. So just go through this documentation, at least for the VPC resources. Okay, S3, EC2, IAM, RDS. So just you need to copy that resource blocks in your resource, and as per your requirement, we need to modify. Okay, this is purely developer job role or DevOps job role? Is this purely
DevOps.
DevOps job role or
DevOps.
it's a DevOps engineer job role? And in the same way, here we are using these data source blocks in the same service. Okay, if you go to the service, they'll give. So here we have the simple storage service, right? So here we have the resources. And next what we have is data sources also. If already one data source S3 bucket is there, that I want to use as the data source. That bucket name I want to give here. Okay, so that bucket name, I want to use that already Route 53 also is there. I just need to add one record. Okay, already in another project, we have an S3 bucket and we have a Route 53 also, but I just need to add one record. Then here I'm creating this as the resource I'm creating is I'm creating as the resource, but that already existing subnet and route table I'm using as the data source. I'm going to use it as the data source. I'm going to use it. Okay. Sure. Any doubts on this? Any doubts? Then we need to enhance this one with the input variables, output variables. Okay, so then we need to do some more like a complex kind of meta arguments, count for each. Like this, all this evaluation not came in one day. In the last 10 years, like we are enhancing these. Finally, like we are using the modules now. We need to understand those modules also. Okay, so we're not writing directly these configuration files like this. We're going to use the modules. Okay. Yeah. Any doubts on this? So spend a lot of time on this documentation part. Spend a lot of time on this. On this documentation part. Please copy that